Hello friends, welcome to Power Electronics. Today we will discuss the single phase bridge inverters. And there are two types of bridge inverters. One is single phase half wave bridge inverter and second one is single phase full bridge inverter. Single phase half wave bridge inverter has kind of drawbacks. We will first look out. So in a single phase half bridge inverter we have two SCRs, two diodes and three wire supply. Here we have taken one assumption that each thyristor conducts for the duration its gate pulse is present. Otherwise, when the gate pulse is removed, the thyristor will get turned off. As you can see here, so this is the gate pulse. If the pulse is presented here, then the thyristor starts conducting, and if the pulse is removed, we have taken the assumption that the thyristor, let it be T1, gets commutated. So we have to take care of that. So if you look at here, this is the half wave bridge inverter, how it works. So you can see that here Vs by 2 is the supply at upper half and Vs by 2 is the supply at the lower half. The load is connected in between. We have two thyristor T1 and T2 with two diodes D1 and D2. So we will discuss it here. When the Vs is a supply voltage, Vs by 2 is the supply voltage, it starts flowing, and the thyristor T1 we have given the gate pulse, so it starts conducting. So the current flows through here and then goes to the load and then comes to the return path. Here the diode acts like a open circuit. Why? Because the diode is placed here in the reverse side, so it acts like an open circuit. At the lower half we have not given any kind of pulse to thyristor T2, so it is not working. So as you can see here, the gate pulse Ig1, that means that we have given the gate pulse to the thyristor T1 and the gate pulse Ig2 is not present. So the thyristor T1 starts conducting here. As you can see here, it starts conducting, and you can see the diagram that voltage Vs by 2 appear across it. So it is V output equal to minus Vs by 2. Also you can apply the KVL here, that is minus Vs by 2 plus V naught equal to 0. So what is V naught? V naught equal to Vs by 2. So you can see here the output voltage is Vs by 2. When the pulse is removed at the thyristor T1, it gets commutated. That means it gets turned off. So the thyristor T1 gets off. So the thyristor T2 we have given pulse here. We have given pulse, it starts conducting. So the current starts flowing here and flows through the thyristor T2 and comes to the return path. So what you have seen that the load current conventionally is given here I naught. The current is flowing opposite to of load current. So that is why it is shown in the negative. So you can see here it is minus Vs by 2. It is in the negative. So again the thyristor here starts conducting, T1 starts conducting, then it gets commutated, then T2 starts conducting. So you can see that how the waveform is represented here. Also, what are the drawbacks of this kind of bridge, half wave bridge? One of the drawback is that it uses three wire supply. So this is one of the disadvantages. It uses three wire supply. As you can see here, 1, 2 and 3 wire supply. So we don't need a 3 wire supply. So for better results, we go for the single phase full wave bridge inverter that I will discuss in the next class. Thank you very much.